Who is Galileo Galilei? Galileo Galilei, 1564–1642, was an Italian physicist, mathematician, astronomer, and philosopher who made significant contributions to our understanding of the natural world. He is best known for his pioneering work in the field of astronomy, including his observations of the moons of Jupiter, the phases of Venus, and the irregularities of the lunar surface. Galileo's discoveries challenged the prevailing cosmological views of his time and helped to pave the way for the scientific revolution of the 16th and 17th centuries. He also made important contributions to the field of physics, including his work on the laws of motion and mechanics, the nature of light and vision, and the principles of scientific inquiry and experimentation. Galileo's work and ideas had a profound impact on the development of modern science, philosophy, and technology, and his legacy continues to inspire scientists and thinkers around the world today. Some text goes here. What were Galileo Galilei's most significant contributions to astronomy and physics, and how did they revolutionize our understanding of the natural world? Some text goes here. Galileo Galilei made significant contributions to the fields of astronomy and physics that revolutionized our understanding of the natural world in several ways. 1. Observations of celestial objects. Galileo was the first to observe the 4 largest moons of Jupiter, which are now known as the Galilean moons. He also observed the phases of Venus, which helped to confirm the heliocentric model of the solar system proposed by Copernicus. His observations of the irregularities of the lunar surface and the Milky Way galaxy also helped to challenge prevailing cosmological views. 2. Laws of motion and mechanics. Galileo's work on the laws of motion and mechanics helped to lay the groundwork for the development of modern physics. His experiments on falling objects demonstrated that all objects fall at the same rate regardless of their mass, and his observations of projectile motion led to the development of the principles of inertia and acceleration. 3. Optics and telescopes. Galileo made important contributions to the field of optics, including the development of the telescope and the study of the nature of light and vision. His use of telescopes to observe celestial objects helped to revolutionize the field of astronomy and led to many new discoveries. 4. Scientific methodology. Galileo's emphasis on empirical observation and experimentation, as opposed to reliance on philosophical or religious dogma, helped to establish the principles of scientific inquiry and methodology that continue to guide scientific research today. Overall, Galileo's contributions to astronomy and physics helped to challenge prevailing views of the natural world and to lay the foundation for many of the key scientific discoveries and innovations of the modern era. His work helped to establish the principles of empirical observation and scientific inquiry that continue to shape our understanding of the natural world today. How did Galileo's observations of the moons of Jupiter and the phases of Venus challenge the prevailing cosmological views of his time, and how did he defend his ideas against criticism from the Church and other authorities? Galileo's observations of the moons of Jupiter and the phases of Venus challenged the prevailing cosmological views of his time, which were based on the Aristotelian and Ptolemaic models of the universe. According to these models, all celestial bodies orbited around the Earth, which was believed to be at the center of the universe. However, Galileo's observations of the moons of Jupiter demonstrated that not all celestial bodies orbited around the Earth, and his observations of the phases of Venus showed that Venus orbited around the Sun, not the Earth. These observations supported the heliocentric model of the solar system proposed by Copernicus, which challenged the dominant geocentric view. Galileo's ideas faced opposition from the Catholic Church and other authorities of his time, who were threatened by the challenges his work posed to the traditional view of the universe. In 1616, the Catholic Church issued a warning to Galileo not to promote heliocentrism, and in 1633, he was put on trial by the Inquisition for heresy. Despite being forced to recant his views, Galileo continued to promote heliocentrism through his work and writings. Galileo defended his ideas through empirical observation and experimentation, arguing that his observations of the moons of Jupiter and the phases of Venus provided clear evidence in support of heliocentrism. He also argued that scientific inquiry should be based on observation and experimentation, rather than dogma or tradition. Although he faced significant opposition and criticism during his lifetime, Galileo's work helped to lay the foundation for the development of modern astronomy and physics, and his ideas continue to inspire scientists and thinkers today. Some text goes here. What was Galileo's role in the scientific revolution of the 16th and 17th centuries, and how did his work pave the way for modern scientific inquiry and discovery? Some text goes here. Galileo Galilei played a significant role in the scientific revolution of the 16th and 17th centuries, which was a period of great intellectual and scientific discovery. During this time, scholars and scientists sought to challenge traditional modes of thought and to establish new methods of inquiry based on empirical observation and experimentation. Galileo's work helped to pave the way for modern scientific inquiry and discovery in several ways. 1. Empirical observation. Galileo's emphasis on empirical observation and experimentation helped to establish the importance of observation and measurement in scientific inquiry. His use of telescopes to observe celestial bodies helped to revolutionize the field of astronomy, and his experiments on motion and mechanics helped to lay the groundwork for the development of modern physics. 2. Scientific methodology. Galileo's emphasis on the importance of scientific methodology, including careful observation, experimentation, and analysis, helped to establish the principles of scientific inquiry that continue to guide scientific research today. 3. Challenge to traditional views. Galileo's work challenged traditional views of the natural world, including the Aristotelian and Ptolemaic models of the universe, and paved the way for the development of new theories and models that better reflected the natural world. Overall, Galileo's work helped to establish the importance of empirical observation and experimentation in scientific inquiry and laid the groundwork for many of the key scientific discoveries and innovations of the modern era. His ideas continue to inspire scientists and thinkers today, and his legacy remains an important part of the history of science and the scientific revolution. How did Galileo's experiments on motion and mechanics challenge the Aristotelian view of the physical world, and how did he lay the groundwork for the development of Newtonian physics? Galileo's experiments on motion and mechanics challenged the Aristotelian view of the physical world in several ways. According to Aristotle's theory, objects with greater mass would fall faster than objects with lesser mass. Galileo's experiments, however, showed that all objects, regardless of their mass, fall at the same rate under the influence of gravity. This contradicted Aristotle's theory and laid the foundation for the development of a new physics that was based on empirical observation and experimentation rather than philosophical speculation. Galileo's work also challenged Aristotle's view that objects would only continue to move if a force was continually applied to them. Galileo's experiments with inclined planes and rolling objects showed that objects would continue to move at a constant speed unless a force acted upon them. This laid the foundation for the concept of inertia, which states that objects will continue to move at a constant speed unless acted upon by an external force. If I have seen further, it is by standing on the shoulders of giants in reference to Galileo's groundbreaking work. Overall, Galileo's experiments on motion and mechanics challenged the Aristotelian view of the physical world and helped to lay the groundwork for the development of modern physics. His work established the importance of empirical observation and experimentation in scientific inquiry and set the stage for the development of new theories and models that better reflected the natural world. Some text goes here. What was Galileo's relationship with the Church and other authorities of his time, and how did his views on the nature of the universe and the role of science in society impact his life and work? Some text goes here. Galileo's relationship with the Church and other authorities of his time was often contentious due to his views on the nature of the universe and the role of science in society. Galileo's support for the heliocentric model of the solar system, which placed the Sun at the center of the universe rather than the Earth, was seen as a challenge to the dominant geocentric view supported by the Catholic Church. Galileo's ideas faced opposition from the Catholic Church and other authorities of his time, who were threatened by the challenges his work posed to the traditional view of the universe. In 1616, The Catholic Church issued a warning to Galileo not to promote heliocentrism, and in 1633, he was put on trial by the Inquisition for heresy. Despite being forced to recant his views, Galileo continued to promote heliocentrism through his work and writings. Galileo's views on the nature of the universe and the role of science in society also impacted his life and work in other ways. He believed that scientific inquiry should be based on observation and experimentation, rather than dogma or tradition, and he emphasized the importance of empirical evidence in scientific inquiry. He also argued that science should be accessible to everyone, not just the elite, and he wrote many of his works in Italian rather than Latin to make them more accessible to a wider audience. Overall, Galileo's relationship with the Church and other authorities of his time was often fraught due to his views on the nature of the universe and the role of science in society. Despite facing significant opposition and criticism during his lifetime, Galileo's work helped to establish the importance of empirical observation and scientific inquiry in the development of modern science and continues to inspire scientists and thinkers today. Some text goes here. How has Galileo's legacy influenced scientific and philosophical thinking in the centuries since his death, and what lessons can we learn from his life and work today? Some text goes here. Galileo's legacy has had a profound influence on scientific and philosophical thinking in the centuries since his death. His emphasis on empirical observation and experimentation helped to establish the importance of these principles in scientific inquiry, and his work on motion and mechanics laid the foundation for the development of modern physics. Galileo's ideas also had a significant impact on the development of the scientific method, which remains the cornerstone of modern scientific inquiry. Galileo's legacy also continues to inspire philosophical thinking about the relationship between science and society. His emphasis on the importance of scientific inquiry and the accessibility of scientific knowledge helped to promote a more democratic and egalitarian vision of science, one that is not limited to a select few but is open to all. His work also highlights the importance of scientific progress in improving the human condition, as well as the potential of scientific discoveries to challenge traditional beliefs and ways of thinking. Today, Galileo's life and work offer many important lessons for scientists and thinkers. His commitment to empirical observation and experimentation, his willingness to challenge prevailing beliefs and dogma, and his emphasis on the accessibility of scientific knowledge all provide valuable insights into the nature and role of science in modern society. Galileo's legacy reminds us of the importance of scientific progress in advancing our understanding of the natural world and improving the human condition, and of the need to continue to challenge traditional ways of thinking in order to promote scientific innovation and discovery. Some text goes here. What impact did Galileo's work have on the development of technology and engineering, and how did his ideas help to shape the modern world? Some text goes here. Galileo's work had a significant impact on the development of technology and engineering, and his ideas helped to shape the modern world in several ways. 1. Optics. Galileo made important contributions to the field of optics, including the development of the telescope and the study of the nature of light and vision. His use of telescopes to observe celestial objects helped to revolutionize the field of astronomy and led to many new discoveries. His work also laid the foundation for the development of modern lenses and other optical instruments, which have had countless applications in fields ranging from medicine to telecommunications. 2. Mechanics. Galileo's work on the laws of motion and mechanics helped to lay the groundwork for the development of modern physics and engineering. His experiments on falling objects and projectile motion led to the development of the principles of inertia and acceleration, which have been crucial to the development of modern transportation and aerospace technology. 3. Scientific methodology. Galileo's emphasis on empirical observation and experimentation, as opposed to reliance on philosophical or religious dogma, helped to establish the principles of scientific inquiry and methodology that continue to guide scientific research and engineering practice today. Overall, Galileo's ideas and work helped to lay the foundation for many of the key technological innovations and engineering practices that have shaped the modern world. His contributions to optics, mechanics, and scientific methodology continue to inspire scientific and engineering research today. and his legacy remains an important part of the history of science and technology. How did Galileo's work on telescopes and optics contribute to our understanding of light and vision, and how did this knowledge help to advance our understanding of the natural world and the cosmos? Galileo's work on telescopes and optics contributed greatly to our understanding of light and vision and helped to advance our understanding of the natural world and the cosmos. One of Galileo's most significant contributions was the development of the telescope, which he used to observe the moons of Jupiter, the phases of Venus, and many other celestial objects. Galileo's observations using the telescope helped to confirm the Copernican theory that the Earth and other planets orbit the Sun, and not the other way around as previously believed. This provided a new understanding of the cosmos and challenged the prevailing Aristotelian worldview. Galileo also made important contributions to the study of light and vision. Two. Challenge prevailing beliefs and dogma. Galileo was not afraid to challenge prevailing beliefs and dogma, even when doing so was controversial or unpopular. He was willing to go against the prevailing Aristotelian worldview and the authority of the Catholic Church in order to promote his ideas about the nature of the universe and the role of science in society. 3. Pursue knowledge for the benefit of all. Galileo believed that scientific knowledge should be accessible to all, not just the elite, and he wrote many of his works in Italian rather than Latin to make them more accessible to a wider audience. He believed that scientific progress could improve the human condition and that knowledge should be pursued for the benefit of all. 4. Remain committed to truth and accuracy. Galileo was committed to the pursuit of truth and accuracy in scientific inquiry, even when doing so was difficult or controversial. He recognized the importance of objective truth in scientific discovery and was not willing to compromise his principles in order to please others or conform to prevailing beliefs. Overall, Galileo's approach to inquiry and discovery offers valuable insights into the nature of scientific inquiry and the pursuit of knowledge. His commitment to empirical observation, the challenging of prevailing beliefs and dogma, the pursuit of knowledge for the benefit of all, and the commitment to truth and accuracy continue to inspire future generations of scientists and thinkers. Some text goes here. What controversies and debates still surround Galileo's life and work today, and how can we continue to explore and engage with these issues in a productive and meaningful way? Some text goes here. There are still controversies and debates surrounding Galileo's life and work today, particularly regarding his relationship with the Catholic Church and his contributions to the development of modern science. One ongoing debate concerns the extent to which Galileo's trial and persecution by the Catholic Church was motivated by religious or political concerns. Some argue that Galileo was punished for promoting heliocentrism, which was seen as a challenge to church doctrine, while others argue that political factors, such as Galileo's support for the Venetian Republic, may have played a role in his persecution. Another ongoing controversy concerns the extent to which Galileo's work contributed to the development of modern science. While many recognize Galileo as one of the key figures of the scientific revolution, some argue that his work was not as revolutionary as it is often portrayed and that other scientists, such as Johannes Kepler, made more significant contributions to the development of modern science. To engage with these issues in a productive and meaningful way, it is important to continue to study and analyze Galileo's life and work from a variety of perspectives, including historical, scientific, and philosophical. By exploring the controversies and debates surrounding Galileo's life and work, we can gain a deeper understanding of the complex factors that shape the development of modern science and the role of science in society. We can also learn valuable lessons about the importance of intellectual freedom, scientific inquiry, and the pursuit of truth in advancing our understanding of the natural world and improving the human condition. How did Galileo's work on the tides contribute to our understanding of the gravitational pull of the Moon, and how did he use his observations to argue against the Aristotelian view of the natural world? Galileo's work on the tides contributed to our understanding of the gravitational pull of the Moon and helped to challenge the Aristotelian view of the natural world. Galileo observed that the tides were not caused by the motion of the wind or other external factors, as Aristotle had argued, but were instead caused by the gravitational pull of the Moon. He used his observations to argue that the Earth and the Moon exerted gravitational forces on each other, and that these forces were responsible for the ebb and flow of the tides. Galileo's observations of the tides helped to challenge the Aristotelian view of the natural world, which held that objects moved only when acted upon by external forces. Galileo's work showed that objects could move as a result of internal forces, such as the gravitational pull of the Moon, and helped to establish the principles of modern physics and mechanics. Overall, Galileo's work on the tides helped to advance our understanding of the natural world and played a key role in the development of modern science. His observations and arguments challenged long-held beliefs about the nature of motion and the behavior of natural phenomena, and helped to establish the importance of empirical observation and experimentation in scientific inquiry. Some text goes here. What was Galileo's relationship with other prominent scientists and philosophers of his time, such as Kepler and Descartes, and how did their ideas and discoveries shape his own work? Some text goes here. Galileo had relationships with several other prominent scientists and philosophers of his time, including Johannes Kepler and René Descartes, and their ideas and discoveries shaped his own work in important ways. Johannes Kepler was a contemporary of Galileo and made important contributions to astronomy and the understanding of planetary motion. Kepler's laws of planetary motion helped to establish the idea that the planets move in elliptical orbits around the Sun, rather than in perfect circles as previously believed. Galileo's work on the telescope and observations of the moons of Jupiter helped to confirm Kepler's laws and contributed to the development of modern astronomy. René Descartes was a philosopher and mathematician who made important contributions to the development of modern science and philosophy. Galileo and Descartes corresponded about various scientific and philosophical topics, and their ideas influenced each other's work. Descartes' ideas about the importance of mathematical reasoning and the need for clear and distinct ideas helped to shape Galileo's approach to scientific inquiry and experimentation. Overall, Galileo's relationships with other prominent scientists and philosophers of his time helped to shape his own work and contributed to the development of modern science and philosophy. His interactions with Kepler and Descartes, in particular, helped to establish key ideas and principles that continue to influence scientific inquiry and discovery today. How did Galileo's work on the physics of falling objects and projectile motion influence the development of modern mathematics and calculus? Galileo's work on the physics of falling objects and projectile motion had a significant impact on the development of modern mathematics and calculus. Galileo's observations of falling objects led him to develop a theory of motion that challenged the prevailing Aristotelian view of the natural world. He recognized that objects fell to the ground at a constant rate, regardless of their weight, and he used this insight to develop the concept of acceleration. He also studied the motion of projectiles, such as cannonballs, and developed mathematical formulas to describe their motion. Galileo's work on motion and projectile motion laid the foundation for the development of modern calculus. His ideas about acceleration and the mathematical relationships between distance, time, and velocity helped to establish the principles of differential calculus, while his work on projectile motion helped to establish the principles of integral calculus. In addition to his direct contributions to the development of calculus, Galileo's work also inspired other mathematicians and scientists to continue exploring the mathematical relationships between distance, time, and motion. His insights into the nature of motion and the mathematical formulas he developed to describe it helped to establish the principles of modern physics and mechanics. Overall, Galileo's work on the physics of falling objects and projectile motion played a key role in the development of modern mathematics and calculus. His insights into the nature of motion and his mathematical formulas helped to establish the principles of differential and integral calculus and continue to influence scientific and mathematical thinking today. Some text goes here. What was the significance of Galileo's famous experiment at the Leaning Tower of Pisa, and how did it demonstrate the principles of motion and acceleration? Some text goes here. Galileo's famous experiment at the Leaning Tower of Pisa was significant because it demonstrated the principles of motion and acceleration and challenged the prevailing Aristotelian view of the natural world. According to legend, Galileo dropped two objects of different weights from the Leaning Tower of Pisa to demonstrate that they fell to the ground at the same rate. While the details of this experiment have been disputed, it is clear that Galileo did conduct experiments on falling objects to better understand the principles of motion and acceleration. Galileo's experiments on falling objects showed that objects of different weights fall to the ground at the same rate, as long as there is no air resistance. This challenged the Aristotelian view that heavier objects fell to the ground faster than lighter objects. Galileo recognized that the force of gravity acted equally on all objects, regardless of their weight, and that the rate of acceleration was constant. Galileo's experiments on falling objects laid the foundation for his theory of motion, which recognized the importance of empirical observation and experimentation in scientific inquiry. His work helped to establish the principles of modern physics and mechanics and contributed to the development of modern science. Overall, Galileo's experiment at the Leaning Tower of Pisa was significant because it challenged long-held beliefs about the nature of motion and the behavior of natural phenomena. His insights into the principles of motion and acceleration continue to influence scientific inquiry and discovery today. How did Galileo's work on the nature of light and vision contribute to the development of the telescope and other optical instruments, and how did these inventions revolutionize our understanding of the cosmos? Galileo's work on the nature of light and vision played an important role in the development of the telescope and other optical instruments, which revolutionized our understanding of the cosmos. Galileo recognized that lenses could be used to magnify distant objects and improve our ability to see and observe them. He applied this principle to the development of the telescope, which allowed him to make groundbreaking observations of the Moon, Jupiter, and other celestial objects. Galileo's work on optics also contributed to the development of the microscope, which allowed scientists to observe the microscopic world in greater detail. Together, these inventions helped to establish the importance of empirical observation and experimentation in scientific inquiry and revolutionized our understanding of the natural world and the cosmos. Galileo's observations of the Moon and Jupiter helped to confirm the Copernican model of the solar system, which held that the Sun, rather than the Earth, was at the center of the universe. His work also revealed the existence of moons orbiting other planets and helped to establish the idea that the cosmos was much larger and more complex than previously believed. Overall, Galileo's work on the nature of light and vision played a key role in the development of the telescope and other optical instruments, which revolutionized our understanding of the cosmos and paved the way for modern astronomy and astrophysics. His insights into optics and his inventions continue to influence scientific and technological innovation today.